Okay, the time is now 12:15 in my time zone, or probably quarter past an hour in some time zone where you are, or 45, depending on where you are. So we're going to get started. I hope you can see and hear me. I am able to see questions that get posted to Q&A, so I hope you'll post lots of questions as we go along. The information that you mainly need to get started is this link that you'll see at the top there, aka.ms/learn/Blazor. So if you follow that, that will take you to the guide that we'll be using for this session, and that'll give you lots of important links to various things that you will be needing. So as you can see, there are a few prerequisites for this session. I think that it's not going to be super demanding. This is going to be quite a beginner level session. So we do mean that C# and .NET experience at beginner level. If you think that you've got some kind of idea about what classes and properties and methods are in C#, then your level of experience is probably fine for this. Your level of familiarity with ASP.NET doesn't matter that much because Blazor is largely a new programming model, so I'm not too worried if you are not familiar with ASP.NET. And we will be using Visual Studio Code as our IDE as we go through this, so a bit of experience with that will help, but don't worry even if you're new to it because it's just like any other software. Okay, so yes, this is of course part of the Build conference, which is going on at the moment. And in this session, we are going to be learning about Blazor WebAssembly, which is a new technology that we have just released yesterday. So it's very exciting. We're still at the beginning of the story of Blazor WebAssembly, but it is now shipped and supported for production use. So you can now get started with building applications for that. And that's what we'll be talking about today. So the agenda is what we're doing now, a little bit of welcome and introductions. We'll then go through the Learn module. I'll be giving you a guided step-by-step process of going through that. And as we go, I'll probably go off script a little bit and give you some extra bits of information, maybe 1 or 2 extra demos as we go along to make things a bit more interesting. And I'll make sure to leave a lot of space for questions at the end. But we're not just doing questions at the end. I will also take questions at any time as we go through. I've got a second screen over to my right on which I can see some questions that are being published by our moderators. So I'll respond to those from time to time. Okay, so your team today is me. I'm Steve. I'm going to be the speaker today. And then we've got 4 wonderful moderators who are online, and they will be receiving your questions and hopefully answering some of them and sending some of them through to me so they can be shared with everyone as well. And yes, as you should know, this session will be recorded, so people will be able to see it on demand later. And yeah, you can post your questions in the chat window. Of course, like all the sessions that are part of Build, this is subject to our standard code of conduct. This is all very sensible stuff that I'm sure will not be surprising or cause us any trouble. So I'm not going to read out all of that, but this is common to all the sessions at Build. It's all very sensible, and I'm sure we will treat each other well and have a good time today. Okay, so to get started, please do go to this link on your own computers now, aka.ms/learn/Blazor. And when you do that, that is going to take you to this web page that you can see here. Build a web app with Blazor WebAssembly and VS Code. You can see it's a 45-minute long module. Okay, so what we're going to do to get started is talk about how to get your machine set up for developing Blazor WebAssembly applications. We'll also do a little bit of intro to what the technology actually is, what kind of problems it's supposed to be solving for you. Okay, so I'm going to move straight on to the introduction, and then after that I'll probably answer a few questions. So before we get into how to do Blazor, let's talk a little bit about what kind of software it's designed to let you build, what kind of problems it solves for you. So let's consider that you are trying to build a sophisticated web application, a sophisticated modern web application that runs in people's standard web browsers on both desktop and mobile. And maybe it can also be installed into people's machines as a progressive web application as well, so that people can just launch it from their start menus, use it offline, that kinds of thing. Okay, now maybe you've got a lot of stuff going on in there. You need a non-trivial UI. You need forms, you need validation, you need dialogues, sidebars, wizards, pop-ups. You need all the grids and other types of UI that will exist in complicated software. You also need to deal with concepts like authorization, authentication, localization, and all kinds of different aspects of optimization that you need to deliver really high quality software. So there's potentially a lot of stuff that you need to think about in the modern world. Things are not simple these days. Now, if you were to go back a few years in time, the only way of building complicated software to run inside people's browsers would be to use JavaScript. You would have to use a JavaScript framework and write your code in JavaScript or something that compiles to JavaScript. And that's been the case for many years. But thanks to modern web standards, that's no longer the only option, because we now have something called WebAssembly, and that allows us to run code from any language inside your browser. And Blazor is a way of writing a single page application with .NET code. And that can run in different ways, which I'll talk about in a second. Okay, so just to add a little bit more to that, to give you more context, let me show you an example of a realistic finished application so you can get a sense of what sort of thing you might be building. So I'm going to open in a new browser tab this demo application called Car Checker. You might have seen this if you saw Scott Hunter or Dan Roth's sessions yesterday. It's something we put together just for this conference here. And the idea of this application is that it's something that might be used by a car rentals company. So in particular, it's something that the staff of the rentals company would use when customers return cars. So when you've hired a car and you return it, they have to check that you've filled up the fuel tank correctly, you haven't put too much mileage on it, and that you haven't created any damage. And if you have, they need to track where the damage is and add photos of it and that sort of thing. So here I am as a staff member in my application, and I'm logged in. So we've got authentication, the application knows who I am. And then when a customer brings a car, I can type in the license number for that car. You can see we've got a nice sort of autocomplete thing going on there. And then maybe I select the vehicle by its license number. And that takes me into a screen where I can see information that we already know about it. So here's the mileage that was on it before they take the car out. Here's the tank level that we expect. And we can spin this 3D view around and see information about where we expect damage to already be on this car. And then the staff member can compare that to a vehicle in real life and try and spot any new damage. So maybe they discover that there's a problem with this rear light here. They can click on that and then they can add a note and they can say, you know, does not work or whatever it is. They can add a photo to it. They can save their changes, and maybe they want to change the fuel level to reflect what the user is, the customer has returned. They can maybe change the mileage. You can see we've got validation there, and then they can hit save, and that synchronizes back to the server. But this doesn't just run in regular web browsers. This is also a progressive web application. So I can install it into my machine and launch it from my start menu or dock or home screen, depending on what operating system you're on. So I could launch Car Checker here from my operating system start thing, and I'll hit that and it will show up, and you can see we've got it in its own little window rather than a browser window, and it's got its nice sort of full UI, but otherwise it's exactly the same as before. Another cool thing about this is that it supports offline use as well. And I can prove that to you by turning off the web server. So let's say I go over here to this terminal window here. This is where the actual web server of my application is. And I can close that down by doing a Control-C. It's shut down now. There's no longer any web server. So obviously it makes no difference whether I'm online or not. Let's see what happens when I start up the application now. Does it still work even though there's no web server we can reach? The answer is yes, it comes up and it works fine. It just can't synchronize changes with the server at the moment. So if I was to go into that car again and make another change, let's say we'll change the tank to be empty this time, and I'll hit save. Then you'll see now I can still save. I can do everything in the application. We just can't synchronize changes with the server. But if the server was to become reachable again later, for example, the staff member walks into an area that's got Wi-Fi, so they get network access again, then they can hit the retry button, and at that point it will actually synchronize back with the server. So that may be important as a business scenario, being able to support offline use for certain types of applications. It particularly makes sense for this one. Okay, so there's a lot going on in that application, and if you want to learn more about how that's been built, we've got an on-demand session, part of the build whole program, where you can see a 45-minute deep dive into how that was built, and it goes through a lot of the code in it. You can also clone the code to your own machine and run it locally if you want to. Okay, so that's an example of a bigger application, but it's not the one that we're going to use during this particular talk. In this talk, we're going to build a smaller application just for you to get started, and hopefully it will make sense even if you've got a fairly minimal level of experience of this technology already. Okay, I'm just going to check right now whether I can see any questions that people want me to answer. I can see that most of the questions have already been answered, so I'm not got anything to answer right now, but by all means keep your questions coming. All right then, so let's move on to what is Blazor WebAssembly? Well, I've just given you a load of background about what kind of applications you can build with Blazor WebAssembly, but just to quickly recap some of it, Blazor is the technology that allows you to build rich interactive UIs with .NET web UIs. So it doesn't involve doing full page reloads every time you want to change the UI. We can change the UI in place dynamically as things happen in your application. WebAssembly, as I've explained before, is a way of running arbitrary code inside your browser. So it's a bytecode format that can be run inside web browsers, which allows you to write code in any language you want. As long as it can be compiled to WebAssembly, then standard web browsers can run it. Now, WebAssembly is not really a new standard anymore. It's been around for about 3 years now, and it's supported in all desktop and mobile browsers that are up to date. So it's a pretty universal concept. And with WebAssembly, you don't write the WebAssembly bytecode by hand. You write your code in another language and then compile it to WebAssembly. And that is how we made Blazor WebAssembly work. So what we did is we took a .NET runtime and we compiled it to WebAssembly. So it's just a normal .NET runtime, the same sort of thing that you would run on your desktop machine or on a server in order to run .NET code. And we've compiled it to WebAssembly so that it can run inside browsers, which means that we can load and execute standard .NET assemblies inside the browser. And that's how a Blazor application works. You can see a list of the browsers that are supported. Like I've said, it's all standard, current, up-to-date browsers. Okay, now I just want to clarify, since it's not mentioned here, there are 2 modes of execution for Blazor. We've got WebAssembly execution and we've also got server execution. Blazor Server has been out for about 6 months now. That shipped as part of .NET Core 3. And that's a way of doing Blazor applications that run on the server with all the UI updates streamed over a WebSocket connection. Blazor WebAssembly is a newer alternative, which we only just shipped yesterday. So hooray for that. And that moves all the processing off the server and into the browser where it actually runs your .NET code on WebAssembly. Okay, I hope that's reasonably clear, but I'm happy to answer any more questions about that. We've got lots of questions that are being answered by our moderators, so I guess I don't need to answer them. Very good. All right then, next thing, let's set up our machine to do some development. As you can see, we're going to be using Visual Studio Code, and we've got a link to that right here in the document. So if you follow that link, if you haven't already got VS Code installed, you can download it for Windows, Mac, and Linux, and that won't take you very long. You will also need .NET Core 3.1. So if you follow this link that's inside the document, you will get to this download .NET Core 3.1, and the particular version of it that you need is the latest version that was released yesterday, and that's 3.1.300. You do need that version, not any older version, because this is the first one that includes Blazor WebAssembly. Now, it's good to check that you've got the right version installed. So if you go to a command prompt on your machine, such as Windows Terminal on Windows or one of the other terminals on Mac or Linux, then run .NET --version. And what you should see, if everything is good, is that you're on 31300. If you see any smaller number than that, then you are in the wrong place. Please get 31300. Also note that you can't use the 5.0 previews because they don't include Blazor WebAssembly yet. So you do need 31300. Okay. Right then, we are going to be using Visual Studio Code. So let's make sure that you've got the right extensions installed into VS Code. So I'm going to open VS Code on my machine right now, and we will check that we've got the right stuff installed. So if you go onto this extensions area here, you can search, and the first thing you're going to need is the C# extension. You may well already have it, but if you go and search for C#, then probably the top thing that will come up is this one, C#. It's a rather popular one, as you can see. So make sure you've got that installed. There's a little green button that you will click to install it, except if you've already got it installed like I have, when you won't see it. Okay. Next, you need to install the JavaScript debugger extension. You might be thinking, why on earth would I want that? I'm not writing JavaScript, I'm writing .NET. Why would I want the JavaScript debugger? Well, Blazor WebAssembly runs on WebAssembly, and WebAssembly runs as part of the JavaScript runtime within a browser. So in order to debug WebAssembly-based applications, this all becomes part of the JavaScript debugging system. So that's just how it works internally. And if you want to actually have full support for debugging your WebAssembly-based applications, you need a very new version of the JavaScript debugger. You need the JavaScript Nightly version. And to get hold of that, you will go and search for JavaScript debugger and have a look until you find this one here, this one with the yellow square and the little bug on it. You can see it's called JavaScript Debugger Nightly. That's the one that contains the latest WebAssembly support. So you install that, but it's not enough just to install it. You also need to enable the latest version of it. And to do that, you follow the instructions that are here. So what the instructions tell you to do is to go to this little cog icon inside the Nightly debugger and choose extension settings. So you're going to that and then scroll down to the bottom, and you can see that we've got, where is it? Yes, you need the use preview version. So you need to enable the preview version of the JavaScript debugger following the instructions that are given there. So hopefully on your machine, you've got a little checkbox to enable that. On mine, I do not, because I've already turned it on. Okay. Right then, so that's VS Code all set up and ready to go. I'm going to close VS Code and we'll go back to these instructions. So someone is saying that the JS debugger does not have a checkbox. It's in JSON. I guess I just saw that as well. Maybe they've just changed that in the last day. I don't know, but you can follow the instructions to enable that. Okay, any other questions coming in that I need to answer? Looks like no. Cool. All right. So let's have a go at building our Blazor WebAssembly application right now. And we're going to build a simple little calculator for calculating the value of a deposit in a bank after it has gained some compound interest over a certain period. So we're going to make a compound interest calculator. And as you can see, the way you can start creating your project is to run .NET new Blazor WASM and then give a name to your project. So that's what I'm going to do right now. I'm going to say .NET new Blazor WASM, and the name will be CI Calc, the compound interest calculator. Okay, so that is going to create the project. It's also going to restore all the packages that we need and get us ready to start building our application. So now I can then cd into that directory there, and I can simply type .NET run, and that will compile the application. And after it's been compiled, it will start up a local web server so that we can see it running. Okay, so it might take a moment the first time you run it because it has to get a bunch of stuff set up internally. But once it gets going, okay, you can see it's now listening on these two URLs. You can have either the HTTPS one or the HTTP one. Well, I'm going to take the HTTPS one and open that URL. So you can paste that into your browser or click it, depending on your terminal. And that takes you into this starting point application. So this is to get you going. It's got some examples of how you can do navigation here. So we've got these 3 different pages we can navigate between like that. And this is client-side navigation. It's not fetching new pages from the server as we move around, because this is a single page application. It's also got an example of this counter here that just counts how many times you've clicked on a button, and an example of how you could fetch some JSON data from an API endpoint and render it as a table. Okay, so that's pretty simple stuff. Okay, so when you are done with running that, you can press Control-C in your terminal to shut it back down, and then we will move on. Okay, any questions that anyone wants to ask now? I see probably not. So just a note to the moderators, I can see that you're doing a great job of answering all the questions. That's cool. If you want me to answer anything specific, then please post a note and mention that you want me to answer it. And of course, I will then do so.
I think we have a good one for you here, Steve.
Yeah.
What are the advantages of Blazor WebAssembly compared to Angular or React?
Great question. Thank you, Syed. Okay, so the kind of scenarios that Blazor WebAssembly aims to solve are very similar to those that Angular and React are solving. So it's mostly a question of what kind of technology set you prefer to use. So if you feel that you have got a lot of background and experience with JavaScript and you're really happy with writing JavaScript, then probably you're going to be quite happy to carry on as you are. However, a lot of people feel that there are many significant advantages to using C# and .NET code. So C# is a very long established language for productivity that many companies and many people feel is able to help them build their applications faster, more confidently and more productively than they would do with many other technologies. It's also a language that is very strong for server and client development. So if you want to do full stack development, where you have the same technology running on the server as you do inside the browser, then Blazor WebAssembly is a really good choice for that. You can have your C# libraries containing your logic running on the server and share code with your application running inside the browser absolutely seamlessly. And hopefully that will make you able to get your work done more quickly. Another thing that's often considered an advantage of .NET is that it's a very stable kind of ecosystem. So things don't tend to change every few months as they often do in the JavaScript world. .NET is engineered to remain as it is and keep you going with the same back-compatible code for many, many years, even decades in some cases. So if you're making a significant investment in building a particular application, then you may well feel that doing that in .NET is going to set you up to have an application that you're proud of for many years to come and not feel that you have to keep rebuilding it with different technologies. So I hope that answers the question, but if anyone's got any other points on that subject, then please do send them along and we can discuss that as well. Was there anything else, Syed?
There's another question.
Yeah.
Are there any plans to include any standard Blazor components within Visual Studio as a toolbox or something similar, I guess, to how web forms used to work?
I see. Okay, so it sounds like that's a question about would we have some kind of visual designer, if I'm understanding correctly. The answer is we don't have any plans to do that at the moment. There's very little customer or developer demand for a visual designer for web-based technologies. I think what people have learned over many years is that they just don't work very well because you simply cannot account for the broad range of things that actually happen inside a web browser. So generally, the kind of web forms style model of a visual designer sort of died out around 2005 or so. And I don't see much sign of that coming back anytime soon. We're more focused on making the actual code editing experience as productive and clear as possible and doing lots of things around things like hot reloading and quick previews and things like that to try and get your experience to be as productive as possible while writing code. But if people are keen to have visual designers, then please do send us that feedback and maybe that can end up getting factored into our product plans in the long run. Okay, so let's move on now and we'll have a look at a little bit of code in the application that we've just created. So the next document here gives you a bunch of information about the different files that you'll see in your project. But rather than just read that out to you, let me show you inside VS Code right now. So I'm going to run code dot, which will open an instance of VS Code. at the current directory. You can also just open VS Code from your start menu and go to the open option if you want to and pick the directory containing your project, but I kind of like doing it from the command line. Now you may see this prompt come up. The required assets to build and debug are missing. Do you want to add them? And I would recommend that you choose yes. What that actually does is it makes this folder called .vs Code appear, and it contains a bit of configuration that helps VS Code know how to start up your application. So if you go over onto the debug tab, you'll see these two options, .NET Core Launch and Debug for Blazor. That's because VS Code has detected that this is a Blazor project and has added the right build configuration. But if you don't get that prompt or you want to add it later, you can do so just by going into the debug window, and then you'll be prompted again. Okay, so let's have a look at some of the other files that are in here. We'll start with the CSproj file. So you will see that this is a standard .NET Core project. There's no weird magic going on. It's just built by the normal C# compiler, and it implements support for Net Standard 2.1, which means that you can bring any NuGet package in that supports Net Standard 2.1, and it should be able to work within the browser. There are actually a few exceptions to that because Net Standard 2.1 has some capabilities that don't correspond to anything in a browser. For example, the ability to listen for TCP connections or do DNS resolution or other low-level things like that that have got no equivalent in a browser. So not literally everything will work. Some things may be not supported on that platform, but the considerable majority of NuGet packages should be able to work fine in your Blazor WebAssembly application. You'll see we've also got references to these packages that we just shipped yesterday. These components.webassembly packages, version 3.2.0, those are Blazor WebAssembly itself, including the ability to build it and run it in a dev server locally. Now we've also got program.cs. So as you will know, if you've ever built a .NET Core console application, this is the thing that runs when the application starts up. So in the case of Blazor WebAssembly, this is going to be running inside the browser, and this is where you add the code needed to configure your application and make it get rendered at a particular point within your web page. So the important one is this bit here where we're adding a particular Blazor component into our web page. And what this does is it looks for an element with the name app in our page, and it adds a component that corresponds to this .NET type called app. Okay, so if you want to see that in more detail, you can open this index.html file, and you will see this is the actual web page that will go to the browser initially, and it's got this element in it called app, and that's where the Blazor WebAssembly bit is going to be injected. And the specific thing that is injected comes from this file app.razor. So what is a Razor file anyway? Well, if you've not done any Blazor development before, I will tell you that a Razor file is a syntax for combining HTML and C# code in order to compile .NET classes. So app.razor is perhaps not the best one to see to get started. An easier one to understand to get started is the one for this counter page. So you may remember from before, we had this counter that you could click it and it would make the count increase. Well, in terms of how that works, that's implemented here. We've got a few things going on. Firstly, we've got this page directive at the top, and that is telling Blazor's router that whenever the user navigates to this URL/counter, this is the component we want to show. So you can see in my browser here, I'm at the counter URL, and that's why counter is being displayed. We've also got some HTML markup here, and below that, we've got some C# code. So one of the traditional ways you might do development is combining HTML and JavaScript. Well, in this case, we're combining HTML and C#. And every time we want to use some C# in our markup, we use the @ symbol. That's the magic symbol that transitions us into .NET mode. So if we want to display this current count, we use @ and then current count, and that's going to be displayed in the UI. If we want to call C# methods from an event handler, then instead of just onClick, which would be a JavaScript event handler, we do @ onClick, and that means you're then calling a C# method. So that's how that stuff is wired up together. And you can go and see other examples of other functionality if you want to by exploring other pages in your site. Okay, so is that everything we're going to talk about here? Yes, so it tells us in the document what Razor components are and how each of them is a way of representing state and rendering logic. If you want to learn more, you can go and check other tutorials and documents about all the lifecycle methods and how events are handled and things like that. But before we dig into that, I think we'll just move on a little bit. Now we've got a little quiz going on so we can check our knowledge. So first one, Blazor WebAssembly apps are powered by which runtime? Okay, so is it the runtime provided by the browser? Is it .NET runtime deployed with your web app, or the JavaScript runtime? Well, I can be a bit of a pedant sometimes, and if I'm in my most pedantic mood, I would answer that all three of these answers are technically true. So technically, yes, we are deploying a .NET runtime with your web app. That's the thing that's running on WebAssembly. Now, WebAssembly is also an aspect of the JavaScript runtime. So pedantically, we could say that this third option is also technically true. And of course, that runtime is provided by the browser. So we could say the top option is also true. But if we're trying to be a bit more reasonable, we probably understand that the answer that the person wants is this middle one. So it's .NET, which is compiled to WebAssembly and then is deployed with your web application. Okay, question 2, how is the UI defined? Yes, we've just seen that it is Razor pages, which are a mix of HTML and C#, so that answer is true. It's definitely not XAML. There's no XAML involved here. And is it C# defined in Net Standard Libraries? Yeah, it is. So if we're going to be pedantic again, answers 1 and 3 are both true. But I think the person writing the questions wants us to give this answer, that it is Razor pages. Okay, so let's just check. And yes, congratulations. We know what we're talking about. Okay, so we will continue. All right. So any questions, moderators? Do you want me to talk about anything that people are bringing up right now?
Yeah. So we have a good question that is, does the compiler warn you if NuGet packages that are not supported in WebAssembly?
Super question. Do you want to answer it, Javier, since you're also a member of the Blazor team and know just as much as I do about this?
Sure. So Blazor WebAssembly is targets Net Standard, and Net Standard is the set of APIs that the .NET Framework defines for the compatibility of applications.
Yep.
So what that means is that when the compiler builds your application, it thinks that the API is there, but then what is going to happen is that at runtime is not going to work because Blazor WebAssembly runs in the same sandbox as the browser. So there are things that are naturally not going to be available. Maybe, for example, opening a TCP port is not available. So what you'll normally see in those situations is you'll either get an exception when you try to use the API. I believe it's something like platform not supported exception or something like that.
That's right.
Or you'll get some other a bit more cryptic error. But normally, hopefully, you'll see platform not supported exception.
That's right. Yeah, great. So if someone comes along and tries to say read or write the Windows registry from inside the web browser, well, guess what? That's not going to work because browsers don't give you a way of doing that. So hopefully you didn't expect that was going to work, but if you were to try it anyway, you'll get some kind of error. Now, if you ever try anything like that and you're confused about why it doesn't work, then please come and post an issue on GitHub and we will do our best to investigate and make sense of whether there's a problem there or whether that should be expected and what kind of alternatives might be there for you. So we love answering your questions on GitHub. Go and post them there. Another point on that is, as part of our work on .NET 5, one thing we're trying to come up with at the moment is a kind of analyzer that will run during the compile process and will warn you about use of any APIs that will not be supported on the platform that you're targeting. So while at the moment we kind of expect you to know what sort of things are possible in a browser, longer term we will hopefully be able to give you automated information about that. Okay. Let's carry on, and then we'll take some more questions after a few more minutes. All right, so we are now going to implement the compound interest feature within our application. So it's advising us to open the project in Visual Studio Code. Now, of course, we already did that. So next it says, how about we add a new page to our application called compoundinterest.razor? Okay, so let's do that. And I'm going to add it to this pages folder here. But just so you understand, there's nothing magic about that folder. You can put your Razor files in any folder you want. It doesn't matter whether it's pages or shared or the root folder. It's just a convention to keep things organized. So I'll do that. I'll create a new file in here called compoundinterest.razor, but I could technically have placed it anywhere I want. Now, I want it to be a page that you can navigate to. And pages you can navigate to have to have this page directive, like that. So I don't have to have a page directive because maybe I'm just writing a component that is a child component of some other page. But in this case, I want it to be a page in its own right. So I'll use the page directive and I'll say I want this to be at what URL? Well, I will do what it says in the doc here of being at the compound interest page. So now I can just start typing some HTML in there if I want to. But let's follow the suggestion in here of adding this particular H1 header. So I'm going to paste that in. OK, and now I want to run it again and see whether that page shows up in my application. So if I go back to my browser and I hit reload, let's see what happens. I get an error, and the error is localhost is not listening right now, and that's because I shut down my web server before. So I'm going to start the web server back up with .NET Run, and that will recompile things and my application will become available again. OK, so that's going again now, and I can reload and my application is back, but there's no new page. Like, where is that new compound interest page that I just created? Well, the answer is it's there, but we just didn't add any link to it. So if the user was to magically know about this URL somehow, I'm just going to paste that URL in there and I'm going to press enter, then I actually do get to my compound interest page. So it's there, but maybe we should add an entry to this navigation menu so we can actually see it. OK, so let's follow the advice in the document here, and it says go to the navmenu.razor file. We haven't seen that yet, but let's have a look at it. So in the shared directory, you'll see we've got navmenu.razor. We'll click on that, and this is quite a lot of markup, but don't be frightened by it. This just provides the contents of that left-hand menu. So we've got these three links on the left, home, counter, and fetch data, and you can see in the code we've got the same thing there. Okay, so each one of those entries is a link, and I'm going to add a fourth one by copying and pasting this, and then I'm going to change it so that the URL it goes to is compound interest, and I'm going to change the text as well to compound interest, like that. Okay, and then I can go back to my browser and hit reload, and do we see it? The answer is no, we still don't see it. What's going wrong? Why don't we see it? Well, it's because I haven't recompiled my application yet. Okay, because all of these things go through the normal .NET compiler to produce an application that runs in the browser. So we do have to compile after we make each change. But honestly, it's quite tedious having to keep going to the console and shutting things down and starting things back up every time you make a change. So as a tip, if you're using VS Code, I would recommend opening the terminal here inside VS Code, and we're going to run .NET watch run. Okay, so that's an alternate way of running .NET compiler, and it will watch for any changes to the source file, and whenever it sees you've changed stuff, it will recompile and restart your web server. So that makes things a little nicer to use. So now that's running, I'll go back and reload again, and you'll see finally compound interest does actually show up. Okay, that's better. Okay, so where are we going from here? Well, we've created a page and we have not put anything in it yet. Let's now put in a bit of UI code so that we can do the actual interest calculations. I'm going to copy the markup for this HTML table, and you'll see it's just normal HTML markup. You can use literally any HTML inside Blazor WebAssembly, and I'm going to hit save on that. Okay, now it also advises us to put a button underneath that will actually trigger the calculation happening. So I'm going to add that as well. Okay, so .NET Watch has seen that we've made a change. It's rebuilt stuff and restarted. So now when I reload, you should see we get the updated thing inside our application. Okay, that's good. But it doesn't really do anything yet. There's no numbers. And when I click on this calculate button, nothing at all happens. So we are going to have to add some extra functionality using Blazor's data bind and events mechanisms. All right, let's take a brief break back to questions. So moderators, is there anything that people have brought up that you would like us to discuss at this moment?
There's been a couple of questions about performance versus JavaScript.
Great. Okay, so in general, performance. So when we run your .NET code within the WebAssembly runtime, we are running it today on an interpreter, which means that it is not as fast as if you run it on the desktop or on the server, because on the desktop or server, you've got the whole JIT compiler, which is going to make things work faster. So Blazor WebAssembly today is optimized for application UI building. And we've done a lot of work to make it as streamlined as it possibly can be, so that even if you're building a really complicated UI with like hundreds or thousands of things going on simultaneously, with like many grids and menus and things changing and graphs and such like that, the WebAssembly interpreter-based runtime should be fast enough to make that still a very fluid and satisfactory experience. So for those scenarios, which is the vast majority of what people are doing, we expect it to work very well. Now, if you choose to do something that is not the target scenario, for example, some GPU intensive workload or CPU intensive workload, like if you try to do Bitcoin mining or machine learning training or something like that, that is not going to perform well at all today. So that's not a targeted scenario. In the longer term, we are looking at ahead of time compilation as a way of getting off the interpreter and running your code directly on WebAssembly bare metal, which will make it many times faster, at which point it would become practical to do CPU intensive workloads as well. But that's not the target scenario for the first version. Like I say, in the initial version, it's all about building rich and sophisticated UIs. And for that, I strongly expect that you should be able to get applications that are just as sophisticated as anything you would build within any JavaScript framework. If you do have trouble with that, then again, please come along to GitHub issue and tell us about what you are doing, and we'll try to provide advice to you on how to structure your application to perform really well. Does that make sense, Syed? Was there any other angle that you think people would want to know about there?
I think that was pretty good. There was another question that came by a while ago that said, can you right-click and show the source in the browser for one of these pages?
I'm very happy to do that, yeah, but it might be a bit anticlimactic because there's very little source in the browser. So if I go to view page source, then you'll see there is literally nothing there apart from what was also inside the index.html file in here. So it's actually identical. So when the page starts up, this is the only thing that is in the UI, and then this Blazor WebAssembly.js script is the thing that knows how to start up the .NET WebAssembly runtime and load your application into it, and then that starts dynamically adding stuff into the document inside the browser. So you don't really see anything interesting when you view source. It's all about loading the runtime and then dynamically building the UI. Okay, right then. So let's move on and add the actual data binding and compound interest calculation to the application. So there's a little bit of background information about how you can add code into your Blazor project here. It tells you that there's two main ways you can do it. You can either use CS files alongside your Razor files, and people often call that the code behind model, and that works absolutely fine. But the method that we're going to use in this talk is to add our code inline in the component. And generally, we recommend that you try to keep the code inside your Razor components very simple. And if you have a lot of sophisticated code, it's good to factor that out into a different separate CS file. And so you will generally have just a little bit of logic inside each Razor file, just enough to handle an event and call some other method. Generally very simple stuff. And because it's so simple, it works really well and is very convenient just to have it inline within your Razor file. So you can always see exactly what the correspondence is between events in your HTML and the .NET code that gets executed. So that's the method that we'll be using here. There's also a bit of background information about Razor syntax. Now, I did talk about that before with the use of the @ symbol to transition between HTML and C#. So whenever you see @ and an expression in your Razor file, that's going to evaluate something and display that in the UI. So you can read more about that. And I also mentioned the page directive, which is mentioned here, which is the thing that associates components with particular URLs. Okay, the last concept that you'll want to know about is the bind feature. That's a way of doing two-way data binding between some .NET properties or fields and the actual HTML UI. So when the user types in a box, it goes into your .NET property, or when your .NET property updates, it also updates the UI. So that's the two-way binding, and we'll be using that just now to implement the compound interest calculation. Okay, so on the next page, you'll see it tells us to go and add a code block at the bottom of our compound interest Razor file. So let's do that. This is how we can add a bit of inline code to our Razor file, like that. Okay, and now I can just start typing C# stuff right there. Okay, and it's normal C#. You can use all normal C# syntax. Let's see what we're going to do in this case. Well, we're going to define a bunch of properties relating to the interest calculation. So let's just copy all that stuff and drop it in. And you can see we've got the initial principal, the interest rate, and various other things. And ultimately, our goal is to update this total string there and display that within the UI. Okay, so in order to actually do the calculation, we've got that implemented in regular C# code. So again, I'm going to copy and I'm going to paste that in. I hope that this is not particularly scary for you, whether or not you recognize this formula, it doesn't matter. We take the principal and we do some math stuff based on the interest rate and the duration of the loan, and we work out what the updated total is, and then we will set that onto the total property. I think there's a mistake here where that particular property isn't required at all, so I'm just going to delete it, and hopefully I don't get any errors. But if I did make a mistake, then the tooling inside VS Code should be smart enough to tell us that you've got a mistake. So let's set that back so that it actually works. Okay. All right, now let's see what effect that has on the application now we've made that change. I'll go back and I'll hit reload, and you'll see that it makes absolutely no difference whatsoever because we're still not displaying anything in the UI. Okay, so how can we display those numbers in the UI? Well, we're going to use the two-way binding feature. So we're going to use @bind on a text box and say what property it is that we want to bind that text box to. We're also going to use @total in order to display the total. Right, so let's copy that. And I'm going to paste that in as the new body for my table there. And I'll sort out the alignment. Very good. Okay, so hopefully now we will actually be displaying these fields in the UI. Let's go back and see if that is the case. Reload, and you'll see we are displaying them. That's good. And I can modify things, and that does actually update the underlying data in .NET. And if I click this calculate button, what will happen? Absolutely nothing happens at all. Why does nothing happen? Well, because we still haven't added any event handler onto our button. So if we follow the instructions in the document, we'll see it tells us to add an onClick. Okay, but we need it to call our C# method. So we want to use @onClick. And if I can type that correctly, then that's how that goes. And you'll see initially it complains at us saying you need to provide a value for that. Okay, if I provide some garbage, then the Razor tooling should tell us that's not right. There is no such method called qui. Okay, so the actual thing we want to call is called calculate, and we've got IntelliSense to pick that out. Okay, so that is now hopefully going to run the computation and update the UI with the result. Let's try it out. Now, when I click on the calculate button, we see it does in fact work. And if I change this duration and reload and hit calculate again, we get a bigger number. And let's make it really big. Let's see if I have a 1,000-year loan, then I am going to be extremely rich indeed, long after I am dead. Or my descendants are going to rule the world, I think. Okay, so we have successfully done some compound interest calculation. Okay, and that's pretty much the end of that. Now, let me give you a little bit of a bonus demo of how we can run the debugger if we want to. That's not in these documents, but I'll show you, and you can follow along yourself if you want to. Let's say we want to debug this calculation logic. If I go over onto this debug tab here, you'll see we've got these two options. We can launch our application or we can debug it. Now, do not launch your application if you've already got it running like I have. You know, I've got .NET Watch Run going, so my application is already running. It's already listening on whatever port it uses. So if I try to launch it a second time, I'll just get an error because you can only have one thing listening on the port at once. It's already running, so I can just choose to debug. Okay, so I'm going to choose that, and then I'll click on the Run button, and that is going to launch in a browser, and then I will be able to actually, set a breakpoint, and hopefully we will hit it. Now, for whatever reason, it uses Chrome by default rather than the browser that I was using before. If you want to change that, by the way, you can. In fact, I'm going to change it right now. So let's close down Chrome, and I'm going to go to my VS Code launch settings, and you'll see this is where it's configured to debug in Chrome. I'm going to change that text to Edge there, and then I'm going to change this type to PWA MS Edge. All right, and that's all I have to do so that the debugger will now use Edge instead of Chrome. So you'll see it says Edge now up here. I'll choose that and I'll choose Go. And again, it's going to start up a browser. It'll use a new browser instance to keep everything clean and fresh. And this time, hopefully, it will be Edge. As you can see, it is. All right, so now I want to have a breakpoint in my compound interest page. I'm going to put it right here in this calculate method. And then I'm going to click on calculate, and you'll see we hit the breakpoint inside VS Code, and we can start to inspect what's going on. So if I hover over principal, you can see that value and interest rate. I can also step like that. And when I did step, you might have noticed that this total variable got updated to whatever it's going to become. I can also expand and see more details about what's going on. I can see the call stack and so on. And ultimately, I can hit on the continue button, and then my application continues running and everything is good. Okay, so that is doing a bit of debugging. You can press the stop button when you're done with that, and it will all close. All right, any questions from the audience at the moment?
Yeah, so we have a couple of questions. One is, how large is the initial download for a Hello World app?
Yep. All right, let me answer that one. So if you are in development mode, the answer is massive, because we don't run the actual proper compression or code stripping during development. And to prove that, let me open up the browser DevTools. I'm using my keyboard shortcut there. I think you can use F12. And if we go over on to the network tab so we can see what gets downloaded, I'll hit the reload button, and you'll see, well, actually it looks like not very big initially. It looks like 279 kilobytes, but that's because most of it is already cached. If we want to get an accurate view of how big it is, we would need to go and clear the site data completely, and then we can reload again, and you'll see that the true first time size is giant, 6.7 megabytes. Okay, so during development, we don't try to optimize the size because that would make the builds slower. However, when you publish, we run the .NET linker, which will strip out any code that is not being used. And we also run a very aggressive form of pre-compression, which is going to use Brotli compression on the highest setting in order to shrink your application as much as possible. Now, out of the box, the project template, when published, produces applications that are about, I think, 1.85 megabytes, something like that. You can make it smaller if you want to by turning off certain features, such as international time zone support or international collation support. You could also remove the Bootstrap styling if you want to drop another 100 kilobytes. So I think the smallest you can make it out of the box today is about 1.6 megabytes. So whether that's good or not for your scenario depends on your scenario. You'd be the best one to judge about that. What we often hear is that people who are building line of business type applications think that that's absolutely fine. And honestly, it wouldn't matter even if it was 5 or 10 megabytes, because, you know, it's being loaded over Office-based networks. And of course, it's all cached after the first load anyway. So after the user has first been to your site, it's probably just a few kilobytes to start it up a second time. Now, for public-facing web applications, it might be too much or it might not. It really depends on your scenario. It's very common for web pages to be in the several megabytes range these days. If you just go to facebook.com or amazon.com and look how big their web pages are, you'll see that they're well into the megabytes range. So it's not disproportionate to have a 1.8 megabyte site if you are building something that really benefits from it. So if you're building a rich UI and you really want the productivity benefits of doing .NET, then I think many people will agree that's absolutely fine. However, if you're building something that doesn't really need any sophisticated interactions, like you're just building a blog or something like that, then it probably doesn't really make sense to be bringing a .NET runtime into that. Does that sound reasonable, Javier, or was there anything else you wanted to add?
No, I think that sounds very reasonable. The main impact that you have is the first load, and after the first load, your app should load pretty fast.
Yeah, it should do. It certainly will be very fast when it's already cached. What was the other question?
So the other question that we have is, in .NET 6, will we be able to create Blazor web apps using the MAUI project template app structure in addition to the Blazor templates project structure?
Yeah, all right. So for anyone who didn't follow the announcements yesterday about MAUI, MAUI stands for Multi-Paradigm Application User Interface, I think. Syed on the call would know more about this than me. And that is a forthcoming way of building cross-platform UIs with .NET, which is currently planned for the .NET 6 wave, although maybe with some previews in .NET 5. I'm not completely certain on what's been decided or announced about that. We are looking into ways of using Blazor within MAUI applications. It's a very compelling scenario. If you think about how many applications are built with something like Electron today, well, it's huge. Electron is probably the dominant way of building internal business desktop applications today. And of course, Electron is used a lot for consumer applications too. Things like Spotify and Teams and many other things are built with Electron. So this whole idea of having web UI in a desktop shell is very popular. And it's pretty obvious that you could do that with something like MAUI too. If MAUI provides a desktop shell, then surely you can host some kind of web-based UI inside it, and surely you could use Blazor to implement that web-based UI. So this is not something we've particularly made any very clear announcements about yet. I think largely it's not something that needs to be announced. It's just kind of obvious that these technologies will work together very well. But I'm very interested to know exactly how much people are excited about that, how much people want us to invest in it compared with other kinds of UI models, and we'll see how things go, because it's all still to be decided, really. Is that it?
I think so for now.
Super. All right then. So we will move on to the final screen now, which is the summary screen, just as we're coming up to the full hour. So we have done what it says here. We set up our development environment to build Blazor WebAssembly apps. We created a Razor component. We added some HTML and C#, and we used data binding to sync to the calculator logic. So those statements are true. We actually did do those things. So hopefully that gives you a good starting point to understand what kinds of things can be built with Blazor WebAssembly. If you want to go further, and I really hope you do, then the first place to start would be the Blazor homepage. So if you follow that link, then you will see the Get Started, and you can go in there and you can go through a whole range of interesting and informative tutorials that show you how to get started on various different platforms and IDEs using both the WebAssembly and server hosting models. It tells you more about all of those kinds of things. In particular, we've got a tutorial, Build Your First App. And if I remember correctly, down here, we've got this to-do list example. So everyone loves building to-do lists. You can follow the steps there and learn how to do that. And if you want a much bigger and more detailed tutorial, then have a go at the Blazor Pizza Store workshop. This is a huge tutorial, which may take you 1 or 2 full days to complete. It's a really detailed application where you build this complete e-commerce pizza store type thing, and you get to do all kinds of stuff to do with things like authentication and progressive web application features, real-time interactions with the server, JavaScript interop, just loads and loads of stuff going on there. So if you want to really get deep, I would go to this and follow through that, and you can become a Blazor expert. So that's all we're going to do today. I'm now happy to take whatever questions people have got, and then we'll wrap it up when it seems like we're getting to the end of that. So moderators, are anything that you think we should be discussing?
Yeah, there's a question here that says, can we switch between Blazor WebAssembly and Blazor Server with minimal code changes?
Yeah, okay. So let's start by describing why somebody might want to do that. So one of the benefits of using Blazor Server is that all of your .NET code executes on the server and not inside the browser, which means that there's very little work that the browser has to do. The browser effectively becomes a very thin client. It's a very lightweight way of deploying your application, potentially much lighter weight than JavaScript-based frameworks, because the only thing you ship to the browser is a little bit of bootstrapping logic, which connects a WebSocket to the server, and then all the UI just flows in over that WebSocket connection. So it starts up very fast. It works with older browsers than Blazor WebAssembly can support, and you get to run all your code on the server. So that's some advantages of server. Whereas there are some advantages of WebAssembly too, which is because your code is literally inside the browser, there's absolutely zero latency when you come to do UI updates, and you can support full offline use as well. So there are pros and cons to both approaches. And in the case where you wanted to somehow combine them into a single application that works in both modes, the answer is yes, that is certainly possible. And we know of many people who have done that today. We've got 1 or 2 demo repos that show ways of doing that. It's not something that we've really tried to streamline within the framework. So we don't have any built-in APIs that say, like, I just want to have both and auto switch between them or anything. You have to understand how both hosting models work and do a little bit of server-side logic in order to be able to serve in both modes. So the answer is, yeah, it can be done. We haven't done very much to help you with it just yet. But if we get a lot of feedback that that's what people want and need, then of course we can look at adding more APIs for that in the future. Next question.
I think you might be good with questions here. There are some questions about getting VS Code configured and all that sort of stuff, but I think you're up to date outside of that.
Super. All right. Well, I hope that's been useful for everyone. It's been exactly an hour, so I think we can wrap this up just now. Thank you very much for being in this session, and by all means, if you've got more questions, then come along to the GitHub repo and talk to us there. And besides that, I hope you have a really great rest of the conference. So that's it. Goodbye from me.